Today's video was originally going to be a comparison of these three camcorders. Well, actually these three camcorders, I can't show you them and me at the same time because I'm using one of them to record this video. But as I started looking into that video, what I realized was there wasn't really an easy way to compare the light sensitivity of the camcorders and the DSLR camera. And well, I'm quite a photographer. I do a lot of nature photography as a hobby, and yes, I do have hobbies besides making videos. And as a still photographer, we typically talk about camera sensitivity in terms of an ISO number, like ISO 100, 200, 400, and so forth. And that's because those numbers originally came from film, and in fact, way back they were called ASA numbers. And you had wonderful old films like Kodachrome. This is a box of real Kodachrome that, of course, these days can't be developed anymore because nobody does the process anymore. But the Kodachrome that I have here had a speed of 64. The other very common film in the old days was Ektachrome. In this case it's 200, but it's often 400, and using these ASA or ISO film speeds essentially means every time you double the number, you double the light sensitivity. So for instance, this film speed of 64, well, was about half as sensitive to light as maybe something with a film speed of 120. And generally we don't have to be that accurate, so we could almost say a film speed of 100 is maybe twice as sensitive as this one, and this one is yet again another notch higher, so it's in fact 4 times more sensitive than the Kodachrome. Now that's all good and well. And if we take something like a DSLR camera, like this one, well, I can set its film speed anywhere down to about 50, but in reality, it can do almost flawless images at up to a film speed about 800, which is incredibly sensitive, really beyond what one would normally hope to do with most color films. And newer cameras do even better thanks to improving technologies in the image sensors. So why don't we just take the ISO speed of this camera and compare? Well, because for camcorders they generally don't give ISO type speeds, which makes comparisons hard, and if it didn't make them hard, we wouldn't be doing this video. What do camcorders like this specify? Well, if you're lucky, and I stress lucky, they specify the sensitivity in terms of lux. And what is lux? Well, lux is about, and it's quite a coincidence, it's about the amount of illumination you get from a candle at a distance of 1 meter, or for the Americans, 3 feet. So this camera has a specification of being able to operate at 3 lux. So if you were about 3 feet away and you had 3 candles, well, we should be able to take a pretty nice picture. Well, sort of. What they've actually said in the specs is that's with the gain set to 18 and something about 16 frame averaging or something like that. In other words, if you're cranking up the gain and the sensitivity of the sensor in this camera in the absolute maximum way, you can get some sort of a usable picture at 3 lux. Now, what inevitably happens when you crank up the gains like that is you start getting all sorts of noise appearing. And by the way, that's not just something that's common to electronic cameras. In film, when you crank up the gain, you start getting more and more noise as well, typically in the form of the grains, the sensitive particles of salt on the film having to get bigger and bigger, so the image gets a bit coarser and in effect noisier. So in many ways that's exactly what would be expected. However, when you crank up the gain of anything to its maximum amount, you inevitably get a picture that is, well, by no means perfect. And ideally what we'd like to do is have an ISO film speed number that corresponds to what I would consider to be a perfect picture. Well, or as perfect as we might be able to hope for. So we need some way of using these camcorders and comparing them to the ISO values of this DSLR, and if we can somehow do that properly, we can get a sense of what the film speed of these cameras would be. And that's what we're going to do in this video. So I've made this chart, and somehow I'll put up a link to it, so if you want to try this yourself, you can grab it fairly easily and experiment. But what we're essentially going to do now is take this chart and mount it on a tripod, actually just about here where I am, and to get it nice and bright I'm going to use an old slide projector and illuminate it with the slide projector, and then focus all three of the cameras on it and take some video. And so we have an apples to apples comparison. What I'm going to do is set the iris and shutter speed to be identical on all of the cameras. And maybe I should explain very briefly what that is. The iris is essentially how big a hole in the lens light is allowed to pass through. So if we make the hole very small, which corresponds to a high iris number like 22 or 30 or something like that, we get very little light. When we make the hole very large, so as much light as possible gets through the lens, that corresponds to a much lower number, like something around, in these cameras, 1.8 or 2, which we would call a fairly fast lens. And we're going to use a value of f8 because that's something that we can easily achieve with all the lenses at a certain amount of zoom, so we're just showing the chart and not much else. And also, as a rule of thumb, f8 is a pretty good number for most applications. Many lenses are typically sharpest somewhere around that range. You get a fairly good depth of field, and well, it's just probably a good value for comparison. The other thing we're going to do is use a shutter speed of 1/30th of a second, and that's because the frame rate of the video is 1/30th of a second, and all these cameras can be set up to do a much shorter shutter speed. A shutter speed, I think they all go to 1/1000th of a second, and some even more, but that drastically reduces the amount of light going in. And typically, if you've got a frame rate of 1/30th of a second and a shutter speed of 1/30th of a second, you end up with, in my opinion anyway, some of the most pleasing videos, because when somebody moves, you don't get a series of pictures where things seem to be here and then here and then here. The blurring effect within each frame somehow, in my mind anyway, adds to the perception of smooth motion. That is, of course, unless we're trying to have a frame rate so high so we can see those individual steps and maybe slow it down for analysis, which is not the normal use of a camcorder. Anyway, so we're going to pick a 30th of a second and f8, and we will set up all the camcorders to that. And I've also chosen a position for the slide projector to illuminate the target such that that gives us a very close to an optimal image in the two camcorders, and in particular the JVC GY-HM100U. What a mouthful for a name of a camcorder. And when I say optimal, I mean that the big white area is pretty close to the maximum brightness that the sensor can reproduce. If you get much more than that, you get into saturation. It turns out that on the HM100 it is a little bit below that maximum, but still quite in the acceptable range of video usage. And in the DSLR, well, we have such a range of film speed, and I say that in quotation marks. We have such a range of sensitivity that we can go for anything where that might not be nearly enough light to be close to saturation to way beyond saturation. Well, here are the results. Now, what you can see is I've pulled the video from each one of those camcorders into the video editor that I use, which is a video editor called Kdenlive. One of the features it has is something called a waveform monitor. And the waveform monitor corresponds to an actual device similar to an oscilloscope that you used to get when dealing with old style standard definition TV. And what it does is it basically draws a line left to right for each of the lines in the image where the height of that line corresponds to the brightness. And as a result, what you get is essentially a left to right graph showing the brightnesses of the various parts of the image, and it turns out to be a very good way of assessing exposure. In fact, it was used all the time before histograms were ever used, and in fact, in my opinion anyway, it's something that is even better than histograms in most cases, certainly if you're used to it, and I use it all the time. Here it is for each of the two camcorders. And you can see as they're set up, the brightest parts, which are here, are very close to the top of the histogram, and those bright areas correspond to the big white area in my test image. Now, the HM200, the 4K camcorder, that top area is just a little bit higher than the one for the HD camcorder, the HM100. And what we're going to do now is take the waveform monitor as I change the settings in the DSLR and watch and see which ASA settings, or ISO settings I should say these days, best corresponds to what was seen in the waveform monitor for each of the two camcorders. And so as I click through the different settings, well, what we're seeing here is a setting of 65 on the DSLR, and that is almost identical to what we're seeing on the HM100 camcorder. So what that tells us is its effective film speed is probably around ISO 65 or something like that, not unlike Kodachrome. Now, if we play around with the ISO settings on the DSLR a bit more and crank them up, well, right here we have a setting of 125, and that's pretty close to what we see on the HM250, the 4K camcorder. So it is somewhat more sensitive, maybe twice as sensitive as the plain old HD camcorder. And that's not completely surprising because the HD camcorder is maybe 5 years older than the 4K camcorder, and of course technology moves on and sensors get better and better. Now, I should also point out that the size of the sensor can make quite a bit of difference, because the bigger the sensor, the more light it captures, but at the same time, the more pixels you have, the smaller each individual pixel's area is, and if you start putting in more and more pixels, the area of each pixel gets smaller and the effective sensitivity goes down. So there is a bit of a compromise between how many pixels you have and how sensitive you want the camera to be. So it turns out that as you would expect, 4K camcorder does have a bigger image sensor than the HD camcorder. And you might say, well, why don't they just make the sensors even bigger to make them more sensitive? Well, because there is a bit of a compromise there as well. If you make the sensor bigger, it costs more to make the silicon, and now you need a bigger lens. And if you're going to have a super zoom like all of these things do, it now makes the optics quite a bit harder, and everything gets bigger and the costs go up. So you don't just make the sensor enormous. Now you might be wondering, what is the effective speed of the DSLR? Well, if I didn't mention it before, what I found when I'm taking still pictures is somewhere around an ISO speed of 800 gives me essentially a noiseless picture, and that's with 36 megapixels, way more than the 8 megapixels or so from the 4K camcorder and the 2 megapixels or so from the HD camcorder. And you might be wondering, well, how did Nikon do so much better with this DSLR? Well, the bottom line is the DSLR is optimized for extracting every bit of light it can possibly do. It has a giant sensor. It has a whole bunch of features that really are not optimized to use for capturing motion, in other words, being a camcorder, even though it can be used as one. And, well, all the compromises were completely different. And in the end, you also have, well, much bigger lenses. If you sort of compare this lens to, well, the integrated lens on our camcorder over here, it's pretty clear that this glass, this lens, costs way more than this one over here. In fact, this lens probably costs, it does cost more than this entire camcorder. So even though you can do better, it all comes at a significant price. The other thing that might be worth talking about is how film and how electronic imaging differs. Well, we can look at that with a fairly standard graph that shows, well, on the bottom here, the amount of light power intensity falling on the film or the sensor, and in this direction, the output. And the output, well, if it's electrical, might be volts. If it's film, and in this case reversal film, it's probably how clear the film is. So what happens? Well, we can sort of imagine that in the middle area where things are not too bright or not too dark, we end up with a nice straight line like this. And with film, well, as things get darker and darker, ideally you'd like the film to get darker and darker, but there is some maximum darkness. So inevitably, what you get is sort of a bending of the curve somewhere around here. And similarly, as we put more and more light on the film, well, more and more of the photosensitive grains get activated, and it effectively becomes a little bit less sensitive, and we have it sort of dropping off like this in a smooth way. And that's really quite nice because, well, if we do have a bit of overexposure, we just sort of get a gradual saturation occurring so that a little bit of overexposure, well, will look pretty good. But now, Let's imagine we have a digital sensor, a CMOS sensor, or a CCD, or something else. Well, the voltage output of a sensor like that essentially looks like this. It's a straight line going up almost linearly with the amount of power, light power hitting it, until it hits a certain maximum voltage level, and then it just drops off like that. So what that means is if you overexpose the sensor up in this region, you go everywhere up to white, and then, well, if the light is any brighter up here, we simply get a uniform white area that completely wipes out any image information. So it's a much harsher curve. Now, modern cameras, modern digital cameras, have various electronics and processing in there to typically smoothen the curve somewhat like this. It still ends up with a completely flat region up here, but it now behaves somewhat more like film and is indeed a little bit easier to work with than the unadjusted, really harsh curve. And this is often part of an adjustment called gamma, but probably can have other things worked in as well. And so that's the difference, and that's also why film has a slightly different look in terms of exposure compared to many of the digital cameras. Now, for our purposes, what we're really interested in is this sort of nice normal exposure region over here. So we'll hopefully set our big white area on the test chart right about here. And so that's what we're going for with our test chart when we're doing the sensitivity testing. We don't want it to be up here to sort of get all involved in whatever these curves might be. And of course, we don't want it down here where it's so dark anyway. We want it really at the top of the useful exposure region of the sensor, be it film or digital. The other thing we should maybe talk about is why on earth do camcorders have gain as opposed to, well, an ISO setting? And I think the real reason is because camcorders started out as television cameras using things like iconoscope tubes in the very early days. That, just like a modern camcorder, feeds the image sensor, which is now a CMOS or CCD sensor, into an amplifier. And in electrical engineering, we typically talk about amplifier gain in dBs. And, well, you can see where I'm going with that. Electrical engineers built the first TV cameras, and they needed some way of increasing the gain and giving it a name, and the easiest thing was to simply name it after the amount of gain in the amplifier. So a 6 dB gain corresponds to a doubling of the light sensitivity. So it's the same thing as going from ISO 100 to 200, for example, when you're going from a 0 dB gain to a 6 dB gain. And typically 0 is set where the output of the camcorder or TV camera is essentially noiseless. So it's probably more of a historical fact or a historical artifact than anything else. So that's, I guess, how the two types of cameras have evolved in different ways. It is kind of unfortunate, and to me it's really unfortunate when they sometimes specify camcorder gains in lux and other times don't specify it at all. And I suspect it might be something like cell phone plans where they really don't want people to be able to compare things too easily. And maybe it's because these days all people care about is megapixels or whether it's HD or 4K. So why muddy the waters, which of course would be detrimental to selling the camera. So what does this all mean in terms of the practical applications of the camera? Now, as a photographer, if you tell a photographer something has an ISO of 65 or 120 125 or something like that, they'll have a good sense of what they can achieve with it. For film or video, we have a bit of an advantage, and that is that we typically deal with what would be very long shutter speeds in normal still photography, namely 1/30th of a second. In still photography, when I do animal photography, well, I'm typically never slower than 1/100th of a second, and often in the 1/500th of a second or 1/1000th of a second if I'm trying to freeze frame birds' wings that are flapping or something like that. So for that sort of use, I typically need much higher film speeds. But with the luxury of 1/30th of a second, well, it's surprising how dim the light can be for a ISO 65 or 120 camcorder to get a very acceptable image. And indeed, both of these camcorders do very nicely inside a house where you don't have any special room lighting or anything like that. And I think in most cases, at the most I've ever had to be able to do is notch up the gain by 1 notch to add 6 or 9 dBs with maybe a slight increase in noise, but not much. I know people have complained about some of these camcorders saying, well, they don't work very good at night. Well, at night there is so much less light that if you're trying to get a really good picture of somebody, you probably should be using external lighting anyway. And for that matter, if you're trying to get a good street scene with all the lights from the buildings and the cars, you don't want it cranked down so far as to make everybody look like they're in sunlight anyway. You want the whole darkness to be dark, and you want the colored lights to be nicely exposed so you see the colors. And it turns out that type of setting is probably closer to the settings you would have in a semi-dim room in a house than trying to get an extremely low lux setting. So that was my unexpected venture into seeing if I could characterize the film speed of these camcorders. And, well, it turned out to be way more interesting than I was expecting, and I hope you felt the same. I will be doing another video doing a quick comparison of these camcorders now that I know how fast their image sensors actually are. I hope you enjoyed this video, and see you next time.